Welcome to our second class on thermodynamics, basics 2. In the first class of thermodynamics, we tried to understand the first law of thermodynamics and second law of thermodynamics. Now in this class, we are going to understand again the basics only. We are not going to advance it so far. So the thermal capacity or heat capacity, specific heat, thermal conductivity, thermal diffusivity. How they are related, we are going to understand with very fundamental or basic information. Simple thermal capacity or heat capacity. Okay, thermal capacity or heat capacity is the amount of heat existing in a body. Say for example, this is the duster. The amount of heat existing in this body is known as the thermal capacity or heat capacity. Now, so what is the specific heat? Okay, the specific heat is the heat capacity, or thermal capacity of a substance in relation to that of water. So this is what we call it as. What is the thermal capacity or heat capacity? Just I would like to enlighten you. Again I am saying that this is the basics only. The thermal capacity of a substance can be defined as the amount of heat required to change the temperature of a given mass of that substance by a certain amount. Okay. Once again, I would like to read and explain to you. The thermal capacity is also known as heat capacity. Now, the thermal capacity by definition, the thermal capacity of a particular substance, take this as an iron rod for example, not duster. Okay, the thermal capacity of a substance can be defined as the amount of heat required, energy required to change the temperature of a given mass of this substance by a certain amount of energy. This is what we call it the heat capacity. The unit of heat capacity is the gram calorie, the amount of heat required to raise 1 gram of water from 15 to 16 degrees centigrade, we call it that. So how we can apply, even though it is basics, I would like to enlighten you on how we can apply it to our agriculture metrology. Surely and certainly in the days to come, definitely all the thermodynamic laws, gas losses, whatnot, everything, applications in agriculture metrology is my fundamental responsibility. So here small two applications I will give. Because of lower heat capacity and poor thermal conductivity, because of the take this as sand, this is the sand. Okay, because of lower heat capacity and poor thermal conductivity, the sandy soils warm up more rapidly than clay soils. Okay, because of these two characters. Okay, thermal properties otherwise. Now, so another application is the energy received by sandy soils is concentrated mainly in a thin layer, resulting in extraordinary rise in temperature. The energy received by sandy soils warm up very quick. Okay, why? Because the energy received by sandy soils is concentrated mainly in the just few layers, small layers, very thin layer, resulting in extraordinary rise in temperature. So if a question comes, why the sandy soils rise their temperature very quickly, this is the reason. So like this innumerable examples as far as our crops, oilseeds, pulses, cereals, even plantation crops, animals, just in the days to come, even forestry, I am going to enlighten you just once again for your academic interest. This is the basics only. Okay, right? Now, let us see what is thermal conductivity. Simple, very interesting. Thermal conductivity. Of course, thermal conductivity we may have to explain in two: thermal conductivity in gases, thermal conductivity in solids. But anyway, general thermal conductivity I will tell in the tomorrow class. I will tell in a gas or in a soil. Okay, first just let us try to understand what is thermal conductivity. The ability, this is for example, the ability of a substance, please presume that this is the rod, iron rod, the ability of a substance to transfer heat from molecule to molecule. If a gas is there, I am breathing it, gas is there, from molecule to molecule, okay? While I am inhaling. So the ability of a substance to transfer heat from molecule to molecule, we call it as the thermal conductivity. Of course, so that's why it is also known as the molecular conductivity. Thermal conductivity is also known as molecular conductivity. It is by definition. If you want by definition, we should know it. Basics 2 of thermodynamics. Now, see, it is defined as the quantity of heat transmitted, because from molecule to molecule, the transfer of the heat is the thermal, okay, conductivity, transfer of heat, molecule to molecule. That's why molecular conductivity we call it as. Now, it is defined as the quantity of the heat transmitted through a unit line of this substance. Presume that this is our iron rod. Per unit cross-sectional area of this particular iron rod, per unit of temperature gradient, 39 to 40 to 40, temperature gradient, per unit of time, in how much. That's why calories per second, centimeter, degree centigrade, there is the units of this one. How? What is the application? Very simple. Once again, even though it is the basic, just to inspire you, I am giving you a small application of this one. The addition of organic matter to a soil, the addition of organic matter. Say, presume that this is the clay soil. Okay, this is the sandy soil. Now, so if I add organic matter to sandy soil, what happens? This is thermal conductivity. Okay, the heat capacity and the thermal conductivity are reduced, of course, but the water holding capacity of the soil, which is added with organic matter, increases. Okay, the water holding capacity increases, but the addition of organic matter to a soil reduces the heat capacity, okay, thermal, okay, conductivity. Okay, these two are reduced. Okay, so this is what simple in the days to come in a paddy field. How, when we give the water from the transplantation to almost 20 days before harvesting, what is going to be the thermal conductivity? What is going to be the heat? That I will explain to you in advance. Now let's go the last one for today's class. Very simple. Thermal diffusivity. What is thermal diffusivity? The expression of the rate at which a substance heats up as a result of the thermal gradient. 39 to 40. So there is a gradient. Now, and this is an expression. Thermal diffusivity is an expression of the rate at which a substance heats up. Iron rod put one side with a Bunsen furnace, the rate at which it heats up as a result of thermal gradient from one end to other end, there is a gradient, that's what we call it as the thermal diffusivity. The rate, in other words, the rate of change of temperature with this is what I found. I always told my basic students in 100 series courses, very simple thermal diffusivity. This is from my side. Okay, the rate of change of temperature with time I used to tell. So this is also, it is proportional to the thermal conductivity and inversely proportional, directly proportional to the thermal conductivity. Thermal diffusivity is directly proportional to thermal conductivity and inversely proportional to the heat capacity. Okay. Therefore, thermal diffusivity is thermal conductivity divided by volumetric heat capacity, or thermal conductivity divided by specific heat into density. Okay, that's what we say it as application of this thermal diffusivity. Just for academic interest, moist soil is more uniform. If a soil, for example, this clay soil you take, this clay soil is given water. So the moist soil is more uniform in temperature throughout its depth, maybe from surface to 5 centimeters to 5 centimeters, 10 centimeters. Say for example, it is more uniform in temperature throughout its depth, as it is a better conductor of heat than the dry soil. It is a moist soil is a better conductor of heat than a moist, dry soil. So this is what is the simple application. Again, as I said, in the days to come, definitely in the crops, in the plantation crop, as far as animals are concerned, and even in the forestry examples, several examples we are going to understand. So this is for the basics on thermodynamics too. Okay, thank you very much. May God bless you.